Hello, my name is Justin Pisarski, and this is my lab report for lab number 1 in Physics 2211. As an introduction to the lab, our goal was to observe an object experiencing constant velocity and use our resulting data to create a computational model through GlowScript, which is coding software for 3D modeling, which would then act as a predictor for our observed data based upon the proper implementation of Newton's second law, or the momentum principle, which I have written out here. The experiment should yield two complementary sets of data, one observed and one predicted, as a means to familiarize ourselves with computational modeling and with what Newton's second law can be used for in regards to how the law functions in practice as a predictor of motion. So for the two main physics principles, Newton's second law and constant velocity, which essentially denotes Newton's first law, Newton's second law gives us the final velocity of an object given that we have these following initial conditions of position, velocity, change in time, net force, and mass. And constant velocity essentially denotes Newton's first law in that the net force is 0, so the mass and the change in time don't really matter. All those would equal 0 here on the right side of the equation, so the initial velocity becomes the final velocity, which means we have a constant velocity in motion until an outside force is acted upon it. The procedure was pretty simple. I recorded an object in constant velocity using my staircase railing in this case. I then analyzed it in a software called Tracker and set up points of mass. I then adjusted the starter code that we were given for this lab to match the initial conditions and compute a prediction based on this observational data. I then brought data points from both the observed data and the computed data into Google Sheets, and then I made a line graph to compare the two visually last. So here is my tracker video. The red diamonds track the center mass of the ball as it moves along the railing. The graph in the top right gives the observed position versus time, correlating with the data. This ruler you see in the back is used to calibrate the system accurately so that it gives me a proper position for the ball. The code in GlowScript, I use the mass of the ball based on whatever the mass of a tennis ball is that I looked up on Google. The ball position vector is denoted by the very first frame, which is the first diamond that I selected in the video I was analyzing and its position, and then the velocity is denoted by the first two frames of the first and second diamond of the analyzed video, where I subtracted the second position from the first position and divided it by the change in time. Here's the calculation loop for Newton's second law. As you can see, my video is 0.934 seconds long, so that is what t is going to be less than in this case, and then the force is 0, so the net force vector is also 0. So here is Newton's second law denoted here, followed by Newton's second law as a second or final position vector, and this is what the code resulted in. The blue ball rolling to the left visually mimics the observation that I made and displays the line chart that shows the predicted position versus time based on Newton's second law, with the green line corresponding to the data points. So here is the results and the line graph that I made to compare the two sets of data. The observed data is in blue, and the model prediction is the straight red line underneath. It starts off fairly accurate, but it ends up losing some of that accuracy and a bit of a discrepancy towards the latter half. I attributed this sort of discrepancy to the fact that the ball is rolling up against a wall, and so friction is slowing the ball down, so it's not necessarily an accurate constant velocity throughout the entirety of the video that I'm observing. However, the line chart still represents a good enough example of how accurate a predicted Newton's second law is, provided that the net force is 0 for the entire duration. However, there is no way of knowing how many forces are acting upon our object at the time of observation, only that those forces, when added together, equate to 0. Newton's second law is such that no matter what direction we choose to travel in our data in the absolutes, provided that all initial conditions are consistent, will always be the same. Should we have chosen to flip our axes so that instead our ball was traveling in the positive x, the direction, our velocity would have been mirrored across the x-axis, visually showing a positive and increasing slope in the first quadrant of the xy plane, and the absolute value of our velocity would be the same. As with the absolute value of our position points, merely the direction of the object would appear to change. Thank you, and this concludes my first lab.